Okay, so for our last bit here, we're going to look at frequency polygons and ogives. Make sure that's working right. So here we're going to talk about something called a class midpoint. So the class midpoint is a point that's exactly between the lower limit of one class and the lower limit of the next class. So some graphs, so used as in histograms too sometimes, but some graphs used for representing frequency or relative frequency distributions require class midpoints. The midpoint of a class is the average of, like I said, the lower class and the next lower class. So we just add them together and then we divide by 2. So that's how we always find midpoints. You add the 2 and then you divide by 2. So in the example that we had, we were talking about the emission ratings. There we go. If I wanted to find that class midpoint, these are 2 consecutive lower limits. So I just take the 0.00 plus the 1.00 and I divide by 2. So what that's going to give me is that's going to give me a 1/2 or a 0.5. If I want to the next one, so 1 and 2, so I'm going to drop the decimals. That would just be 1 or 2 plus 1 or 1 plus 2. Let's keep an order here. The 1 plus 2, and then we divide by 2. So this is 3 over 2. This would be 1.5. Okay, so this is showing the same thing. So you'd have a midpoint 0.5, 1 at 1.5, 2.5, 3.5, 4.5, 5.5, and 6.5. Okay, these are points that sit halfway between each class. All right, so going back to when we made a histogram, so sometimes when we do histograms, I think my tool's not grabbing there. What we do is we don't always use lower class limits. So this is sometimes when we use midpoints. So we use those midpoints in between. So, and like I said, if we were looking for midpoints, the midpoint we'd had here, we said was 0.5. And then here we said was 1.5, and then 2.5, 3.5, 4.5, 5.5, and 6.5. I remember it was just the difference between these lower limits. That's how we found them. So sometimes what they do is that instead of using, like I said, like the 1, 2, 3, so those lower limits, they'll use those midpoints instead. Like I said, this is just one of the cases where sometimes midpoints are used. It's just another way to make a histogram. We're going to use this for a few other different graphs though. So if you ever were looking for other histograms, you may see them like this. So certain kind of graphs like the frequency polygon is one that would definitely use your mid-class points because we're just trying to represent this whole class as one point. So we're not looking at like a range of values for that point. Like we were doing with the histogram, we'd have, between 0 and 1, we construct that bar. This one, we just want 1 point. So this is like making a scatter plot. So you think of this as like your X and this is your Y. So you're just graphing that X and Y. So you use that midpoint between the 0 and 1, that 0.5. And the frequency is 9, so you graph a point there. Then you'd use this as like another set of points. So we have 1.5 and 26. And then 2.5 and 11. And then 3.5 and 13, 4.5 and 3, 5.5 and 1, and 6.5 and 2. And then all we do after that, as you can see, is that we just draw a line connecting all those points together. So this is all that a frequency polygon is going to look like. It's just supposed to be like you want to make pairs of points to represent that class. One's the midpoint and one's the frequency. Let's just put that down here again. Just remember that these are going to just be the midpoints. Usually you're not using relative frequencies with this one. Okay. So using that spider data, we'll bring that all up here in a second, but we're going to make ourselves a frequency polygon chart with us. Okay, so if we want to make that frequency polygon, we need to find these midpoints. So remember, we're looking at the essentially what is the average of two class limits. So if we look at these two, we have 17 and we have 20. So we're going to add those together and divide by 2. So what we'd end up with is a 37 divided by 2. So we'd end up with 117. So we would have an 18.5. Does that seem right? Okay, let me double check that. Yeah, 18.5. I don't know why that didn't seem right. So we'd have an 18.5 would be our midpoint here. So as a kind of like a trick here, so like with classes, the distance between these classes was 3, right? So we could do that for the lower limit, just add 3, and the upper limit is just add 3. So just notice here with the midpoint. So the next two that we would look at would be these two. So we'd have 20 and 23 are my next lower class limits. I divide by 2, that is going to be 43 divided by 2. So this would end up being 21.5. So the only difference between these two is a difference of 3. So this all comes back to we established originally that our class width when we did this is 3. So you could kind of cheat your way through this and get all your midpoints. But if once you get the first one, you could just keep adding that 3 and then you'd just get the rest of them. That's the wrong color. So if you average next 23 and 26, what you should end up with is you're going to average out to 24.5. If you average 26 and 29, then you're going to get a class midpoint of 27.5. If you do the average of 29 and 32, then you should end up with a 30.5. Get off there a second. If you average the 32 and 35, that's going to be a 33.5. And then the last one, so remember this ends at 37.9. So if you were still doing this way, doing the averages, the next class would have started at 38. But this one would end up averaging out to a 36.5. Okay, so we'll create these axes much like the way we did for histograms. So I'll put my frequencies along here. And then the class, or in our case, what the class is representing is lengths. So you don't usually write class down here, you write what it is we are actually measuring. We are measuring the lengths of Carolina wolf spiders. And what we list here is we're just going to list those midpoints. So we have an 18.5, a 21.5, a 24.5, 27.5, 30.5, 33.5, and then 36.5, because I could have a little more room here than I thought. I was just going to make dots. So we said treat that as an ordered pair. So I want to go to 18.5 up to 16, make a point. Then we're going to do 2.15 and 0. So that point would be here. 24.5 and 7. I have a hard time seeing that one. 27.5 and 3. So that's about here. Then we have 30.5 and 6. And then 33.5 and 6. And then we got 36.5 and 2. So we just connect that. So usually what we do is we connect these, and I'll explain how we connect the next part. So we like it to touch the axis. So what we do to make that happen is that we kind of go extend out. So if I had one more class, I would have been at 39.5. So I stretched that out, and obviously I'm going to hit here. If I went backwards one more class here, so I subtracted 3, I'd be at 15.5. So then this one would actually land here. Okay, so that is one way frequently we do those polygons, is we like them to touch the x-axis. Or sometimes the way your book does it, it doesn't really care. And it just leaves it suspended. Oh, I missed a point in here. Let me go back. I forgot we had that point down here, so let me graph that one more time. So we'd go to here to here. I didn't see it for some reason. There we go. And then our last point was here. There we go. So like I said, so usually it's like that, but sometimes you'll see where they want to extend it out and make sure it touches the x-axis at where the next class would have been. Okay. So then our last one is the Ogive. Oops, sorry, before I do that, let's fix something. So Ogive is very close to the frequency polygon. It's just one thing that's different is it uses cumulative frequency. So how cumulative frequency works, I'm trying to get my right tool here. Cumulative frequency is going to do this. So what it is we have our frequencies, and then we're just going to keep adding them up. So my first frequency was 9. So when I start my cumulative frequency in the first class, I'll have 9. Then what I'll do is I'm going to take that 9 and I'm going to add the 26 to it. And then that's going to give me 35, which is my next one. Then what I'm going to do is I'm going to take that 35 and then we're going to add this 11 to it, and that's going to give me 46. So that's my next cumulative frequency. So we just keep adding the next frequency on. Then I would take 46, and then the next place we have 13. So I add that 13 on, and we will end up with a 59. We take the 59, and then we have a frequency of 3 here. So we add on that 3, we get 62. We put 62 here, we add on that frequency of 1, it's going to give me 63. I put that 63 here, and I add on that 2, and that's going to give me a frequency of 65. So this is just adding up all those frequencies. So we do a similar thing. Like I said, we're going to do this, but with the Ogive, it's going to be very similar to that frequency polygon, except instead of using a midpoint in frequency, we ended up using a midpoint in cumulative frequency. So Ogive is constructed. Oh, sorry, you just in upper limits here. The Ogive is constructed by plotting a point for each class. The x-coordinate is going to be your upper class limit, and then your y-coordinate is your cumulative frequency. Sorry, I put that backwards earlier. Was that a little off? Then all the points are going to be connected with straight lines. So in this case, these are these upper limits because you remember the class was this. And then the next one was here. So in this case, we're just taking those upper limits. So we're taking like, what's the max? And then we're adding to it over and over again. So these ones are kind of nice to see, like cumulatively over time, what are we gaining in something? So in this case, we're doing the particulate emission one right here. So we are going to reconstruct another one. But we're going to use that wolf spider data one more time. Okay, so I know I cut off a bunch of the data here, but we already had this all organized. So in this case, if we want to make the Ogive, I need my upper frequency. So it's just going to, or my upper limits. So I'm just going to record all my upper limits. So I'm going to need those, and then I'm going to need those cumulative frequencies. All right, so this is no longer needed because we got those upper limits like we needed. So as far as frequency goes, so I start out with the same frequency. My cumulative frequency is going to be the same as my regular frequency. And then I'm going to take it and I'm going to add on the next frequency, which happens to be 0. So we're going to be at 16 again. Then I'm going to add on the next frequency, which is 7. So that is going to put us at, see, 423. Okay. And then what we'd end up doing is we'll add that 3 on, and then we're going to end up with a 26. Then we're going to add that next one, so that's 6. So we should have a 32. Then we're going to add on the 6 again, so we end up with a 38. And then we add on that last frequency of 2, and we end up with 40. So make sure I had that right. I think I'm off my number. No, maybe I'm not. Plus 7. Okay, no, I'm good. I think I miscounted what I had for spiders. So it's throwing me off. So this should add up to how many of the actual items that we had. So I believe we did have 40 spiders. 3 plus 6 plus 6 plus 2. Okay. So then what we're going to do, pick a different color here. We're going to make our chart. We're going to do pretty much what we had done before. We're going to need one side that's going to have to be our frequency. And then one side, and then this part down here is going to be putting all our upper limit. So once again, it's still representing length of Carolina. Let's try this again. Carolina wolf spiders. And then here's going to be frequency. So we'd end up having, we'd have our 19.9 here, and then we would have our 22.9, our 25.9, our 28.9, our 31.9, and I'm running out of space, so I know this is tight, 34.9, and then we have a 37.9. So we put all those down here. So those are the lengths of those spiders. Then I'd put my frequencies here again. So let's say we want to top out at 20. So this is my 10. So 15 would be here, 5 would be here. It's not scaled perfectly. 1, 2, 3, 4. 1, 2, 3, 4. 1. Oops, no, we need to go up to 40. That's right, because that was my last frequency. Let me do that again, sorry. So because this is at 40 now, then we top out at 40. Get rid of some extra stuff here on the side that's taking up some space. Okay, so this would be 40. And we'll say 20 is here, so 30 is about here, and then 10 is about here. So we'll get pretty close and just sort of kind of guess this. So we'll mark our flags on here. We won't mark every single point. So this first one, what we're going to use is, we don't care about this anymore. Our first point is going to be the 19.9 and a frequency of 16. So that's going to place it roughly here. Then the next one's going to have the same. So it's showing you that there was no change from here to here, which is what cumulative frequencies will tell you. So they're going to kind of tell you about change. Then we get to the next point. So my 25.9 to my 23. So that's roughly about here. And we see that now there's a change. So we had a group of spiders here, and then there wasn't a change when we went to the next class, and then the next class we saw a change. So we got more of them here. So my next one is going to be the 28.9 and the 26. So that's going to be just a little higher than this one. So a little bit more change. Then the 31.9 and the 32. So we know where 30 is. 32 is roughly here. The next one is 34.9 and 38. So that's about here. And then my last one's at 40. And we're going to connect little lines to all these again, so we kind of see what's going on here. So we see that we kind of are steady at first, and then we have slowly are changing. We're getting more and more and more. So it's kind of telling us it's really just telling us a change between variables is what cumulative frequency is going to show us. We change a lot here and here, and then it starts to slow down a little bit.